Again, I used some slides from other faculty's lecture and also textbook. So first, a pre-knowledge. I have showed how to do DNS query, because DNS name is very important for the email system as well. DNS, well, I believe I did some overview before basic. I reviewed the DNS a little bit in basic networking principle. So here is what you need to remember when you do this email spam and phishing learning. Every record in DNS system is called a resource record. It's also say RR record. And you can think DNS is a very large distributed database. It is maintained by tens of thousands DNS servers all around the world. And every entry in the DNS is called RR record. Every entry basically has this four value: name, value, type, and TTL. Type basically show what is the type of this resource record. Like the most dominant type is the type A. Type A is the foundation reason for why DNS was created. DNS was created because people can remember a name very easily, but people cannot remember the IP address very easily. But computer, on the other hand, computer can use IP address, use this digital number very, very easily. So the DNS was created just to make sure that people memorize the name. Then when they type in the name, computer can directly find its IP address. When you type in the domain name for a server, your computer will basically do a DNS query to find what's the type A record for that name. So name is a host name, like eustace.ecf.ucf.edu. So that's a name. The value is basically the IP address for the type A record. So name and value. Value will be the answer. Name is what you ask in your question. So DNS is a very simple service. It only has question, query, and response. DNS query is sent by client. DNS response is sent by the DNS server to all the queries. The TTL value basically is the time to live, is how many seconds this value is valid, how many seconds this answer is valid. So all the local DNS server, once they get a query's answer, they will save that answer on the local DNS server up to this many seconds. So that's how a local DNS server determines how long should I cache that answer. So within that time to live value time period, if I receive another query from my local computer, I don't need to ask that question again. I can directly give the answer to the client. So type A record is the main one for DNS. But once DNS was created, people found DNS is very efficient and very scaling up, because it can maintained by thousands of DNS servers. So it scale up very easily. And then people try to maximize the usage of this existing large-scale distributed database. So they create many other types. So one type is type NS. NS is, the name is a domain. The value is the authority DNS server for that domain. So this just means that if you want to find what's the official DNS server in charge of, in charge of you, I will not use the UCF as an example, because my DNS query is within campus network. So if you want to find what's the DNS server, official DNS server that in charge of, for example, UFL.edu, U Florida. U Florida is an organization. UCF is another organization. Then you use this dig ns command to find what's the ns query type for this ufl.edu. So for type ns record, the name is the question. The question what I ask is ufl.edu. The value is the name of authority DNS server. So this answer part, this entry will be appear in that value entry. So DNS server tell me that there are 3 official DNS servers in charge of ufl.edu. Basically, every domain name that ended with ufl.edu, if you want to find its IP address, you get the official answer from one of these 3 NS servers. So that's what does this NS means? Because if you want to connect to, for example, mass.ufl.edu, your local DNS server will find what's the official DNS server for ufl.edu, find one of them. Then your local DNS server will query what's the type A record for that mass.ufl.edu to this server. So you get the accurate answer from one of those official DNS server for that organization. So NS record is used for that purpose. UCF has four official DNS server, but UCF official DNS server is actually outsourced. So outsourced to Microsoft. So Microsoft Cloud provide this official DNS server. So UCF has already outsourced. It seems the UF has not outsourced their official DNS server. They still maintain their own official DNS server. So let me see. I'm gonna stop name. Yeah. So you can see from name whether they have outsourced or not. UCF have used Microsoft for all the cloud service. Anyway, that's a type NS. Another is a type CNAME. CNAME is basically what's a nickname for what's the official name for a domain name, because many times, just like for human, your legal name may be very difficult to pronounce. So in many cases, in your daily life, you will use a nickname for yourself. So all your colleague, all your friends will call you by nickname. It's very easy to memorize. But your legal name could be very difficult, very long. Just like my legal name is in Chinese, so it's hard for American to pronounce. So I always use my nickname Cliff as my first name. So this CNAME is basically for the same reason. For any domain, they may provide many nicknames, so people can remember them very easily. What related to email is this type MX. MX is called mail exchange. Mail exchange is represent email server. So that's the official name. The value is the name of the mail server associated with the name. Okay, so it's a little bit confusing. What do you mean associated with the name? Suppose you want to send an email to someone in UF, and that your friend email is your friend name at ufl.edu. But ufl.edu is not the domain name, is not the host name for the email server. ufl.edu is just that organization's domain name. So if you want to find what's the actual email server in responsible to ufl.edu, you just do this query, dig mx ufl.edu. And this is actual email server. Email server's host name for ufl.edu domain. So you can see that the UFL is actually outsourced its email service to Microsoft. From this email service domain name, you can see that it has been outsourced. How about UCF? UCF, our email account is always be your name at ucf.edu. So if you do this, dig MX, basically query for the MX record. So you can see that UCF is also outsourced its email service to Microsoft. There are still some universities, they don't outsource their email service. They still maintain their email service by themselves. I don't know how many of them out there. Let me see. Well, it seems many universities, they have outsourced. They all to Microsoft. I tried. It seems all the universities, they have outsourced to some cloud, to Microsoft cloud. Can I find one? Not. Oh, it's hard to find a university that haven't outsourced their email service. If a university hasn't outsourced its email service, you should find the email server's domain name and with that email server's with that organization's domain. I think all the large organizations, they all outsource their email service to some cloud. But it seems all the university I checked right now, they all outsource to Microsoft. Okay, so this is how you find an email server for an organization, just using this MX record. DNS query, this is, I think DNS query is very simple. So this is query's header. And then the question is here. The answer is here. Identification is just a unique ID because a client may send multiple DNS query to a server. So if you want to distinguish when the answer come back, if you want to know this answer is corresponding to which question, then you need to have a unique ID. So this identification is just a unique ID. When a client sends a DNS query, it will randomly create a unique ID for that query. Then when the answer comes back from DNS server, you know this answer is for which query I sent out. Flags is basically say whether this message is a query, whether this message is a reply. So flag only has two values. Basically tell you this packet, if you use Wireshark to capture this packet, then you can, from this flag field, you can know that this is a query message or this is an answer message. And flag also have some other usage, like whether this query, there are two versions of the query method. I will not explain here, but flag can also show that. And whether the reply is authoritative. If this reply is sent by the official DNS server for that organization, then the flag field will indicate that. If this answer is a cached version, for example, local DNS server, once it cached the result, it's not expired. When it returns that result to the local client, the flag will show that this is not an authority reply because it's a cached version of the answer. Then this is a question. Here's the number of questions, because in one DNS query, you can actually query, you can actually ask several questions, like what's the IP address for this host name? What's the nicknames for this host name? So you can ask multiple questions. Then the answer could be multiple answers for that. So in this way, you can save this round trip time. You can, for one question, you can get all the answer. So this is the message format. And actually, when in the you can do dig command in the department use this machine. If you don't have a Linux machine by yourself, in the use this machine, you can also do dig command. You can also do dig command. Dig command is basically some DNS query. If you don't put any option here, then it basically query for type A record for that host name. And you can see that question section is what's the type A record for google.com. The answer section is that this is the answer. The type A record for google.com is this value. And the TTL value is 86. 86 just means this answer is only valid for the next 86 seconds. So if you do another dig, you can see this answer has become 44 seconds and 39 seconds. You can see this time to live value will decrease in terms of second. So if this time to live expired, the local DNS server that I send this query to, it need to get the official answer from this official DNS server in charge of google.com. You can see this is 12 seconds. Oh. One second. And next time when you send, I will get answer because local DNS server, the previous one expired. Local DNS server under this query, it needed to query for the official DNS server in charge of google.com to get answer. So this is the new answer returned back by the official DNS server. And here is just multiple IP address for google.com. So basically this answer, the time to live value is maximum is 300 seconds, is only valid for 5 minutes. Now it have been reduced. For one destination, you could have multiple IP address because for many web servers, especially e-commerce web server, there could be a cluster of hosting that web server. So then your client, if you are doing this by your browser, then your browser can connect to any one of these IP address. So this will achieve the load balancing purpose. So DNS service can provide this load balancing service. You can have hundreds of IP address for one single server. Then the DNS server can give one IP address to each client request. So all the client connection will be balanced among those hundreds of IP addresses. So server here just to say, this is a local DNS server I'm getting the answer from. This is local DNS server I'm getting the answer. So this is a question section. This is a answer section. And this is a flag field. And the query is one query, answer is 6. So you can see there are 6 answers. Query is only one. I only sent one question, but I got 6 answers. So in the use this machine, in the Linux machine, you can use dig command. In Windows machine, you can use nslookup command. nslookup, if you check for a specific type of the record, you use this dash type equal to check that specific type for that host name. A few years ago, students still use this knights.ucf.edu account. And if you want to find what's the email server in charge of this knights.ucf.edu account, you can in the use machine you can dig mxk nice ucf.edu, and you can see that it is outlook.com. So Knight's student account is also outsourced to Microsoft. And here the answer actually has the additional section. The additional section tell you what's the IP address for the email server. Because normally if you ask what's the email server's host name for an email domain, the reason is because you want to connect to that email server. So the answer not only give you the host name, but also give you the IP address so that you don't need to ask the second question again. You will get all the answer in one batch. And here there are 4 IP address for the email server. This AAAA record is the IP version 6 address. Basically tell you that for this email server, their IP version 6 address is this one. So IP version 6 is actually supported by all the software and the hardware and operating system. It's just that people rarely use them. Okay, for emails, electronic mail, there are 3 major components. One is the user agent, another is mail server, then this simple mail transfer protocol. It's called an SMTP protocol. It defined how email server, they talk to each other, they exchange email with each other. User agent, right now not many people use user agent anymore because user agent is just a dedicated software that you can organize your email and retrieve email from your email server account. Like originally this Outlook, like Netscape Messenger, these are all well-known email agent software. But right now we mostly connect to email server directly using browser. So using browser in that way, there's no email agent anymore. And how email works, this SMTP, well, email system is probably one of the first protocol widely used in the internet. When internet become reality, people immediately create a SMTP service to send simple email to each other. At that time, the email only has text-based things. Just like our text message, originally text message only support you send ASCII character to each other, and it's limited to certain bytes. But right now, the text message, you can send audio, you can send image to each other without any problem. So email is also like that. Original email SMTP protocol, you can only send text to each other. And it's very simple. It's also based on pure ASCII command, because when SMTP was designed, it was late 1970s, and people only use a text-based terminal, and everything need to go through keyboard text typing. So all the command is ASCII text. All the response is also ASCII text, and there is no encryption. Everything is in plain text. So email command, SMTP command is very simple. Here is a basic procedure for you to send the email to each other. So it's mail from, receive to, and data. The email server SMTP service, the email server, the reserved port is port 25. So an email server by default, it should listening on TCP port 25 for incoming email connection. Let me demonstrate that how you can send the email manually. You don't use an email agent. You do not use a web interface to send email. How can you send email using pure command line to do that? I will demonstrate that. So when you connect to the use case, this is the use case machine, and this is a Linux server. You use Telnet, then the email server's host name, and Telnet 25. Telnet a host name and specify 25 means that I want to set up TCP connection to this host name on port 25. So that is a TCP connection setup. So Telnet program right now, it just serve as a TCP connection setup tools. And this connection setup doesn't require user login. So email system, the SMTP protocol does not require login process because there is no user login. This SMTP protocol is the protocol for email server and email server. They exchange email with each other. So there is no login process. So this is the hello message, the welcome message from this department, CS department email server. It supports eSMTP protocol. This is extended SMTP protocol. So it's the second version of SMTP. This is this email server's software. SendMail is the email server software. This is the software's version running on the Sun this version of the Linux machine. And the first command is hello. Remember this hello is HELO. It's not HELLO. Hello, basically you tell the server what's my email domain. Suppose I say, this is my email domain. The server doesn't check whether you are legitimate to claim that you have the email domain or not. Remember, SMTP was designed in late 1970s. At that time, there's no attack. People never worry about attack. So they trust everything the other people say. So here is the same reason. It trusts what you said. Then mail from, this mail from basically tell what's the sender's email domain. Here, this need to be a valid email domain because here it will verify whether the domain name is valid or not. So I need to put in a valid domain. Suppose I put in a valid domain as cn.com. No, fake. This one, it will verify this email. So mail from should be an email server. Basically, this is what claimed to be the sender's email server. It will check whether this email domain exists or not. So it checked that domain does not exist. So I needed to use a valid domain. So fake boss, I can say cn.com. Because cn.com is a valid email domain, so this checking will pass through. So you can see that this checking doesn't check whether that email address exists or not. It only checks whether that email address domain exists or not, whether this at cn.com exists. So whether there is such a username in that email server, it doesn't check. So it says senders okay. Then recipient two. Recipient two basically tells the email server what's the destination email address I want to send this email. So here you need to put in a real email address. Otherwise, the email will not go to anywhere. So let me put my own UCF address here. Remember, this email address can be arbitrary email address. It can be a Gmail address. It can be a Yahoo address. It doesn't need to be an email address for under with UCF.edu. So recipient 2, you can put multiple recipient 2 here, like RCPT2. You can put multiple recipient 2 address. So in this way, you can send one email to hundreds of receivers. After that, you put the data command. The data command basically start to create content for the email. The email data part you can have from boss. Here you can put anything, and because it doesn't check. And the first 3 lines always say from to subject. These are what displayed at the receiver's email client. So subject test from EU CMS in class subject. Then it will be the content of the email. First line of text email. Second line. Was. And if you want to enter the typing of the email content, remember here is a text-based email, pure text-based email. You put a single dot in a line, then you press enter, then the email will be finished, indication of the finish of the email. So right now the mail sent out, you can type quit command to close the TCP connection. So the email, what you show the from to subject, this will show up as the receivers as the from field, to field, and subject field. And after that, this is actual the text in the email content. If I check my okay, so here I have showed you can see this boss to employee and subject. So this is a from field. This is to field. This is subject line. These are what I typed. Here. This from to subject. And actual content of the email is this part. So first line, second line, you can have an empty space line. It's still treated as part of the email content. So that's why for SMTP protocol, it defined a single dot in one line as the end, as indication of the end of the data command input. What? Data part. Yeah. The data is the command. Is one command in the SMTP protocol, just like receive to is one command. This mail from is one command. And this hello is another command. So these are the several commands for you to generate the SMTP email. So it's hello, mail from, receive to, and data. So only 4 commands you need to memorize. You don't need to remember other commands. Only 4 commands here. Of course, quit is close the connection, but if you don't quit, eventually your TCP connection will time out. So you can try it from the use case. Once you log in using SSH to log in your use case machine, you can try these steps by yourself. And just a telnet a server name on port 25 to establish TCP connection to the email server. And the from to subject, they are what shown in the normal email display. They are not actual SMTP command. They are all the line inside the data command, but they were interpreted by the email server as the display entry for this from to subject line in this received email to the end user. A server may or may not support relay. Relay just means that the server can help you to send this email to an arbitrary email address. So that is called a relay. If the server does not support that, then you can only send to an email address on this email server. So on the Longwood email server, the email address is at cs.ucf.edu. So that's the email account for the CS Longwood email server. So if it doesn't support relay, then you can only send to someone at cs.ucf.edu. You cannot send to someone at gmail.com. So that's what this relay means. Relay just means that I can help you to forward this email to anyone you want. So that's the relay. It's 11:47. Let's take a 10 minutes break, and let's resume the class at 11:57. We will finish the second half of the class. Okay. Pause the recording. Okay, let's resume the class, the second half of the class. So one issue is that you can only run telnet to connect to the Longwood email server from the Eustace machine, because from other machine, when you do telnet connection on port 25 to the department email server, your sending request may be denied because the department server only support this relay function from a limited number of connection requests. If you're connecting from outside, it does not support that. Otherwise, the department email server will quickly be discovered by attackers, and attacker can utilize it to send out millions of emails to many users. So that is one question. So if you do telnet from your own host machine, if you run those steps, maybe you can still set up TCP connection, but you cannot go further than that. Like if I'm doing it from my computer right now, this is my MacBook's terminal. If I do telnet Longwood, telnet does not exist on the MacBook. You need to install Telnet first. Um, Oh, in MacBook is a pre-installed. It's called NC to establish TCP connection. Let me try that. NC. It doesn't. Okay. Well, anyway, this route does not go through. But anyway, it's just if you do telnet from your computer, your command will not go through um, successfully. Okay, let's move on. What I demonstrated a moment ago is pure text-based email by using SMTP command. Because SMTP protocol was designed when people only do text-based communication. They don't do any audio or video or image communication with each other. But in the current world, effective spam and phishing email, they always use image to try to fool the end user. They want to use image. Like this is a spam email I got a few years ago. It's from this Bright House. And because my home service at that time using Bright House service, if you don't have if you are not aware of phishing attack, then you may fall to the trick that you may click this My Service to log in to your Bright House account. And when you click this link, you will be linked to the attacker setup web server. The attacker setup web server will have exactly the same outlook as the real Bright House login page. If you are not suspect of that, when you put in your username password, you can actually log into the Bright House account because the attacker web server will redirect your connection to the real web server. But at the same time, they will know your username and password through that way. So this is a phishing attack. So phishing attack always use this very nice outlooking email. And email will have a graphic, will have links. And how do we generate that kind of email? This is because this is talk back to how the email was evolved in the past 30 to 40 years. So at beginning, when the internet was designed, people always use email to send a very simple text message to each other. I find it very convenient to communicate with each other using email. But as they rely more and more on email exchange, they find that they need to send some documents to each other because internet was used officially by some national lab and some universities research lab. So those researchers, they want to exchange some document. They want to exchange some data. The document, the data, they are not in pure text format. Then they need to find a way to exchange that. But how can they build that function into email? So basically, they need an email to be able to send some attachment to each other. But SMTP protocol can only support 7-bit ASCII text transmission. So for every byte, the most significant bit is ignored by SMTP protocol. So in order to send a data file, a document to your colleague, the researcher at that time, they do this way to send email attachment. They use this base 64 program. This is a very simple program. This program basically transfer all the arbitrary byte stream into ASCII text stream, because ASCII text only use 7 bits. The arbitrary data file, all the 8 bits in every byte has been used. The base 64 is basically remove this most significant bit from every byte and put it to the end of this file. Basically, original file may be 100 bytes, but after use base 64, it will become 120 bytes, because additional 20 bytes is because it removed all the most significant bit from every byte and put them in the end. So that's the base 64 encoding. So they first use base 64 encoding to make this file to become a pure ASCII text. Then they append this pure ASCII text to the email. Remember, email is a pure ASCII text-based transmission. So you copy and paste this into the email. When the receiver receive it, receiver just extract this text, save it into a separate file, then use base 64 to reverse to do the decoding and to recover the original file. So what you received is 120 bytes. When you use base 64 to do the decoding, it will recover the original 100 byte data file. Then the data file will be recovered. I was in undergrad. I was undergrad student in 1991 to 1996. So at that time, in the first 2 or 3 years, I actually use this way to send documents to each other, because in the first several years, we use this way to send Word document to each other to exchange our homework, to exchange our writings. And this way of email transmission of the data file is very troublesome, because it needs both sender and receiver know how to do it. And it's very easy to make mistake, because when you transfer data file like several kilobytes Word document into a pure text file, it will have several thousands of bytes. When you copy that to an email, it's very easy for you to copy 1 byte more or 1 byte less when you copy and paste. When the receiver receives it, it needs to copy from first byte to last byte without missing 1 byte or copied 1 byte more. Otherwise, when you do decoding, you cannot recover the original data file. So in many cases, we need to send this data file multiple times. So one time, then my friend cannot receive it because it's just a garbage. Then I need to send it second time, then maybe third time. So it's very troublesome to do this. But this operation is actually very tedious, very, very regular operation. So people quickly realize that we can make this email server program to deal with this encoding, decoding things. So that is called a MIME protocol. So this MIME protocol was designed in the early 1990s. So my undergrad study is during that transition stage. So I used both way. This MIME protocol was designed at that time in early 1990s. It basically makes the email server to take care of this attachment encoding, decoding way. And for the email server and all the user agent like Outlook or Netscape Messenger program, this software, they will encode by 64 base 64 program. They will add this text as a header to that part. So this is base 64 encoded data in ASCII text format. And before that, this header will be added. This header will be added to that text, and this will be automatically attached to the text-based email. So this way is the MIME version. Because the MIME 1.0 is good enough, so after 30 years, we are still using MIME, this version 1.0 for our email attachment. This is a content transfer encoding base 64. So we are still using base 64 for encoding. And content type is what is the type of this data file. It also have this content file name information. So there are many header added. This is one example. This is content type is text plain. This is a character set using this. And quoted printable. So this is because this is already text-based thing, so it doesn't do any encoding. But for the second file, like this is a PDF file, and in the header it has its PDF file name, the size, and content transfer encoding is base 64. So for PDF file, we need to use base 64 to do the encoding. For Word document, we also need to use that to do the encoding. So you can check your own email for that. For example, I find one email. This email does not have attachment. Let me find one with attachment. Okay, so this email has two attachment and some text. If you want to see the full version of it, let me see, download. It download to this EML format. EML format is opened by email agent, but we can use text to open it. Let me change this suffix to become txt. Then I use a simple text editor to open it. Oh, okay, this is too small. Let me. Make it bigger. Okay. Okay, so this is that saved email. You can see this is original email with the two attachments and some text in the email. And after you can do this for yourself because you also have this UCF account. Just go here and download. You will download the entire email down. And I rename it as text because everything is in pure text format. So that's how the SMTP portal works. And this is the email is the receive from. So it has the entire email content, receive from, receive from, receive from. And it's a lot of header added by the email server. This is added by email spam detection software. And anti-spam. This is Microsoft because UCF email using Microsoft system. So Microsoft the anti-spam mechanism as something. This is MIME version. You can see that we are still using MIME version 1.0 for all the attachment. And here the first MIME receive. Okay, so here is basically the content type. Here is header added by that MIME protocol. basically the email has multiple parts, multiple sections, and the boundary is a byte stream. Just identify what's the boundary between each section. So this is the starting of the from to subject line section, and this is that section that that boundary byte stream. So this will begin the second section. For this section, the content transfer encoding 7 bits. So it's a text because this part is HTML file. So this is a HTML format for that email. And here is this is boundary. Remember, this is that boundary type text stream. And the content type is PDF. And file name, this is the first attached file name. You can see that this is the first attached file name. And transfer content transfer encoding base 64. So that's added by the MIME protocol. And this is a file name. Then here is the beginning of this PDF file. The PDF file is encoded in this ASCII text. So so you can see why if we do it manually, it's very easy to make some mistake because it's very long. When you copy and paste, if you select 1 byte more or 1 byte less, the receiver cannot decode it correctly. So this is that PDF file. And when is the end of this PDF file? You find that boundary text stream. I don't know why this is so long. Sorry, I think the attachment is too long. This is a big PDF file. This is the end of this substring. There must be another end of the substring because we have 2 PDF attachment, but it's too long. I cannot just easily find it. So anyway, this boundary string is used to indicate what's the end of one section, what's the start of the next section. So that's how the MIME protocol works. So these are all done by the program. Then for the receiver mail server, it also read this and extract the corresponding content and decode it using base 64 and then save it with this file name, provided file name. So that's how the MIME protocol works. So this is how you send an attachment using email. How about those fake URL link and image, like in all the phishing email? They have images and or they could have URL in it. So for an image, you can include it in email in 2 ways. One is that you can include image as a reference, as a URL. So your email has in the HTML format. Then the image is referred as a URL link. So the image itself is not included in the email itself. It's just the image is referred by a link. And when the receiver receive it, receiver's browser or user agent, they need to extract the image from this URL link. They need to grab this image from the URL link to display it to the receiving user. Another way to include an image is included as the content, as attachment for the email. So you include the image content with the email. So the image content will become one attachment. And so attachment will become like image GIF, then this image file name. Again, it uses base64 for the encoding. So that's that's a two-way to include an image in an email. For example, when you generate an email, what was I sent to? You can insert an image, insert a picture, like, for example, as simple as this, insert picture like here. And so this should be included as the image content itself. Or you can insert a URL link, a web link, like if I want to get this, because on my homepage, this one, no, this one is an image. So I will copy image link. And display it out, image link. This one doesn't show up as the image picture. Yeah, this Outlook, it seems it doesn't have this both way to do that. I remember Gmail has the way to do that. Like in Gmail, if you want to send, you can send image using insert photo. You can upload a photo. So this will be treated as a content. So let me. And another way you can insert a photo by using web URL. Like the web URL is this one. Use this three cannot. Let me go to my CS web servers, like this name. Insert image. Okay, so these two show up as two images, but actually they were included in the email in two different ways. You can also insert a link, like if you insert a link to, like suppose my homepage, but you display text as a different way, like HTTP. Then you send email, And let's come back. Okay, this one is sent from Gmail to myself. You can see that both show up as image, but actually they were treated differently. This first image, it actually included in the email content itself. So email become bigger because you have an image. But second image, it's not included in the email itself. The email only include its URL reference. So the image, whether if it's very big, it doesn't matter. It doesn't increase the size of the email you send out. The third link, I want to demonstrate that you should not trust any link in an email, because if the link show the Bank of America, you click it, you may not connect to the what displayed here, because whatever URL you connect to is embedded under this link. Like whatever you connected, you can see you connect to my homepage. So this is how attacker to fool you. They give you to say a legitimate name as a URL, but they actually let you click and connect to their own web server. But their web server was set up in the same interface as Bank of America website. So if you don't pay carefully to the browser's URL section, you may wrongly think that you're connecting Bank of America, and then when you log in, then your username password will be revealed to attacker. And when you log in, you can actually log in successfully, because once the attacker's web server get your username password, they will forward your connection to the real Bank of America website. So you can still set up the connection with the real Bank of America website successfully. So you will not be aware that your password and account has been revealed to attacker. So that's the phishing attack. So how do we know these two images are treated differently? We can simply download this one. So this one, I want to. Oh. And if you check this full content of this text, and you can see this first image is a signature.png multi-part. This is that URL link. So what displayed is Bank of America, but what actually URL you connected is this URL. So you can see that the first image, this is my signature, is actually included as a base64 encoded image. So the image is treated as a normal attachment to the email. So the image is included here. So here is all my signature part. But for the second image, it's not treated as a mine attachment. Second image is just a reference, URL reference. You can see this image source signature. This is the reference to my name. This is a URL reference to my name. So the second image is not actually included in the email itself. So the second image, you can be very big. It doesn't increase the size of your email. Okay, so these are the two ways for image in an email. How do we generate the figure-based spam email manually? Well, I found out it's not easy. Just like this way, you need to do everything manually by using base 64 encoding, and that's not easy task. So originally, I gave the assignment, ask you to generate a figure, you will spam email with image, but I found that many students will do it wrongly. When they generate the email, the image will become garbage text to show up. So I removed that requirement. So the basic procedure is that you send this email to yourself by using web-based email service. Then in like on UCF account, on Gmail account, you can create an image-based email and send to yourself. After you receive the email, you show the original text or you download the email as a pure text on your hard drive. You copy the text of the email into a pure text editor. In a telnet manual spam sending, after the data command, you paste all the text there. So basically it means that you let the email system to process the MIME protocol to generate the pure text. Then you copy everything into your spam email. You can send to arbitrary receivers. The data section, you have this MIME processed text. So it will be correctly deprocessed by the receiver. So that's how you can do this one. Manually send image-based email or HTML-based email. I mentioned this a moment ago, just outside campus network, department email server does not accept this email sending service because if the department server allow this, then attacker can use department CS email server to send thousands of email to like a Gmail account, to Yahoo account. Then our department email server will become a spammer's machine. So that has been disabled. In early days of the email system, in 1980s, there is no attack. People don't worry about the attack. The only limitation is the resource. The email server are limited. And also networking connection is very unreliable. So your network connection could be frequently interrupt. So at that time, all the email server, they support this relay function. Basically, they will allow anyone to send email to anyone else. So it's just like all the email server, they are open house. They will serve everyone to come in, no question asked. So in that way, if the user's own email server does not work or cannot connect, the user can connect to any other arbitrary email server on the internet and let them to deliver your email for you. So that's the open relay in the early stage of the internet. And mail relay, mail server can help each other to deliver this mail through multiple hop to the final destination. But in these days, that's not possible anymore because open email relay will be used by attacker. Attacker, once they find any email server is in this open relay status, they can let the email server to send out tens of thousands email to many users in Gmail, in Yahoo, in any email service. So all the relay has been closed. The email server only allow this relay from a specific sending source, like only allow message from local IP address, message from the client that are authenticated and authorized to do that. And all the email command, we have demonstrated that the hello command, mail from command you can lie your identity without any question. The SMTP protocol doesn't check. So that's why spammer can always lie that they are from your IT department. Remember this from to. Remember this from to line in the email we received, like this from to line. This to line can be arbitrarily created by yourself under the data command. So any information show up as the from and the to in the email you received, they are not trustable because they are arbitrarily entered by the sender. The email server does not check their identity. So if you see a from is from your friend or from your boss, you should be aware that this is not trustable. And in an email header, it could have a lot of received from. This can give you some clue of which email server this email has passed through. An email may pass through multiple email server because the email server support forwarding service. Like if you send the email to my Gmail account, that email will be automatically forwarded to my UCF account by Gmail server. In that way, I don't need to check multiple email server anymore. I just need to check one email server. For all the email received by my other email account, I can still get them because it will automatically forward by the Gmail service. So this receive from you can see the trace of which email server has gone through by the email. However, this receive from is also not trustable because they can be added by attacker manually when they generate this spam message. Attacker may do that because they want to fool your forensic analysis. If you want to find the true source of the spammer, you may not be able to find that because attacker could add a lot of this fake receive from in the email, and you may not find the true sender. So to deal with this spam email, to deal with this fake email, there are many defense mechanisms. The first widely used is called a blacklist. It's a real-time blacklist, RBL, real-time blacklist. Though right now the famous one is the Spam House and the Spam Corp. They provide service like our department server, CS department email server. It used the Spam House service, and you just need to install a software module on your email server. That software module will periodically get the list of the blacklist into this email server. When the email server receives an email from those blacklist IP address, the email server will label this received email as spam. So that's the basic idea for the blacklist. But as more and more people using blacklist, spammers also try to circumvent this blacklist. So there are many ways for spammer to circumvent blacklist as well. They can use one machine to send out a bunch of spam for just 5 minutes. Then they transfer to another machine to send out a spam for another 5 minutes. So even if you can do blacklist is always delayed because once you discovered a machine is actively sending out spam, you put in the blacklist. Then when the email server get that blacklist, it will several minutes or several hours has been passed. The attacker can simply jump to another machine to send out email spam. So blacklist is accurate. It doesn't have false alarm, but it's not that effective anymore because attacker use all the avoidance techniques to do that. Blacklist could possibly have false alarm because some email server maybe they also have legitimate user on them, but the email server has been exploited by compromise or exploited by attacker. Attacker use that email server send out spam. If that email server was put in a blacklist, those legitimate users, they cannot send email anymore because of the blacklist. So spammers can evade the blacklist by hiding its source IP address. So, so what's the spammers techniques? They can using any relay they can find on the internet. Open relay. Like because there are tens of thousands email server created on the internet, you can always find some email server that was created by new person that don't know how to create an email server. Then when they create this email server, not carefully, the email server may support open relay function. Once it found out by attacker, by spammer can use that machine, send out tens of thousands of spam. So that's open relay. So for carefully designed email server, your relay should be very carefully configured, not allow any unauthorized user to go through you to send email. File for overflow vulnerability. And also some machine, when they compromised by some worms or attackers could set up open relay by themselves. So because the email server, if you do it just to support basic command, the email server could be a very tiny program. So attacker, once they compromise a machine, they can run this tiny email server program in the background without affecting the computer's performance. Then attacker later on, they can use this set up open relay email server to help them to send out spam. An attacker could also find some proxy, web proxy. There are many web proxy on the internet. If a web proxy was not configured carefully, the web proxy could allow the client to specify what's the destination IP address, port number. I want the web proxy to work. If a proxy allows that, then attacker can use this proxy as an open relay as well to connect to the port 25. Then you can send a SMTP command. Because web proxy, they usually allow the client to specify the destination web server's port, because there could be some web server, they are using non-standard port for their web service. So, but if you also allow port 25 in this customized port, then your proxy will be exploited by spammers as open relay. There are some web server provide the service, help you to find the open relay. Of course, they need you to pay some fee. So then they will give you what's the updated list of open relay out there on the internet. Okay, another way for attacker to circumvent this blacklist is using this so-called SIG-pipe method. Attacker, once they compromise multiple machines, they could dedicate some high-end computer as that with a high-speed broadband connection as the precious computer. For the other compromised computer that has very limited resource, they treat them as some low priority control computer. Then when they try to do spam campaign, the low bandwidth computer, it doesn't have resource to send out a large of spam very quickly. So attacker uses high-speed machine, compromised machine, to send out tens of millions of spam in very short time. But if you directly use this one to send out, this IP address will quickly appear in the blacklist. Then it will be blocked by many email servers because of this dynamic blacklist. So attacker don't do that. They want to save this computer to use it as long as possible. So how do they do that? They use this low-end computer as the bodyguard or as a double to be in the front. So when they let this computer to set up TCP connection to the target email server, and then this computer send the TCP sequence information to this high-speed machine. This high-speed machine will send the bulk of the email data to this target email server. Remember here, it doesn't use its own IP address. It uses LSZ's computer as its source IP address. So when the email server sends back acknowledgement, like TCP connection, when you receive data, you need to send an acknowledgement. The acknowledgement will always go back to this computer. But this computer will always tell the high-speed machine what's the corresponding acknowledgement that I have received. Then this machine can maintain the TCP connection. Because maintain a TCP connection, the most important thing is to maintain that sequence number, acknowledge number, to follow this TCP retransmission protocol. So even though I cannot receive that information, this bodyguard, the double, always receive that information and tell me, so I can maintain the TCP connection. In this way, I can send the tens of thousands of spam email to this email server without revealing my IP address. So if this low-end machine's IP address is appeared in a blacklist, attacker simply use another low-end machine as the double to be in the front. So this is a way for attacker to maintain its spamming power without wasting this computer's resource. This one is always hidden in the dark. So that's the thick pipe method. Any questions for this method? Okay. There are some software that allow attacker to send out spam. It's a like this send safe is one such kind of software. It allows you to connect to many open relays, many proxies. It will monitor each email, whether it is sent out successfully or not. You can create an email using different email address and different content. Okay, so how about anti-spam techniques? This is a law discovered in development 2004, but it's not that efficient. Just like do not call list for cell phone, it's not that efficient. You will always receive some telemarketing call on your cell phone. You cannot block all of them. Once you block phone number, they can change another number to call you. The technical way for defend against spam, there are two popular technical way have been developed almost at the same time. Both of them are widely used. One is their purpose, they are all for standard verification. As we know that a spam email can be sent by anyone. So the most important to verify the sender's identity. So it's called a sender. This method is called SPF. It's a sender policy framework. So if the sender say mail from as from a user from Hotmail, then the sender should be an email server in charge of the hotmail.com. If you are not in charge of hotmail.com, why do you send a mail claim that you are from hotmail.com? So that's a basic idea. So if you say your mail from is from hotmail.com, then when I am the receiving mail server, I will send a DNS query to query what is SPF record for hotmail.com. This SPF record basically shows what's the email server's IP address in charge of hotmail.com. So that's the SPF record. If a organization, if they want their email server to support this SPF, they need to send this their own SPF record to the DNS server. So they need to publish this information to the DNS system. Then other user, when they check, then they can check the SPF record. So this one, I basically suppose myself is right now is receiving email server. When I receive this claim from a user, I will ask DNS query, what is SPF record for hotmail.com? And this record should tell me that this two IP address is in charge of this hotmail.com. Then I will check if the sender's IP address is in this list. If the sender's IP address is not in the list, then this email is highly possible to be a spam. So that's the way for this system to work. Let me see if I can find SPF record. So here show the two host name for the, oh, here is a question. There is no answer. So I asked a question, what is SPF, but I didn't get the answer. So maybe this query is not, they want to query the SPF record for a email domain. It's a dig txt, so it's not a say SPF, it's a dig txt. So txt like ucf.edu. Okay, so it query for the, well, it's not called SPF, it's called txt record. Then the answer is that UCF is this and this, and so basically it said it's a 3 entry, but actually you should combine them together. This is VSPF1 is AmazonSES.com. I'm not fully understand what's the meaning for the SPF record. It just showed for UCF or email account, it has the SPF record in the DNS system. And it's not as simple as what I displayed here. It's just a list of IP address, because our email have been outsourced to Microsoft. So that's how Microsoft deal with its SPF record. So it's a TXT record. Let me see Hotmail. So it has this, you can see this SPF version 1 is this IP subnet. So, so this list of IP address is all in charge of hotmail.com. So this is for SPF version 1. It has additional include. I'm not sure what does the include means here. Probably means that these are also good for the SPF record. And I'm not sure about this part. Google site verification equal. Okay, so this just showed how this SPF works. Another one is also for sender verification. It's called DKIM. It is based on public key verification. Normally we say PKI is used widely for the web server, because web server they have the fee to pay for annual fee to get the certificate. So they can get certificate signed by certificate authority, but that need pay the annual fee. Most email server, they don't want to pay that annual fee for any digital certificate. If you don't have a certificate authority certified certificate, then how can you distribute the certificate, distribute your public key in a more reliable way? So DKIM is a way to distribute the sender's public key to each other. So this is basic idea. The sender sign the message, then receiver check the sender's signed message. Receiver get sender's public key using DNS. So using DNS, you can get public key without paying any fee. And the sender doesn't need to get a certificate to pay annual fee to get certificate for their public key. They just need to announce their public key to the DNS system. A user can query the DNS system to get a sender's public key. Of course, this way we find, that this public key could be spoofed by attacker, because DNS system is essentially is open system. So anyone can publish a DNS record in a DNS system. So this is not that secure, but it provides certain verification. So that is called DKIM. So SPF is more widely used than the DKIM method. Besides, this one need to use run public key cryptography, so it take a little bit more time. So this is SPF DKIM, and actually in the email we downloaded before, like this email I sent from Google. This is the email. This is this email I sent from Gmail to my account, and this is download. You can see the header. You can see the header received from, and authentication. Authentication result SPF pass. So it shows that the sender's email address is in gmail.com's authentication list. So sender's IP is this one. This is within this SPF record list for gmail.com. So this SPF checking has passed. And DKIM is none. So this message is not using public key for signature. So DKIM has not been verified. Message is not signed. So here is the explanation. SPF is pass. Domain of gmail.com designate designate this IP address as a permitted sender. So that's the SPF checking. A gray list is that when an email server see this triple value that has not seen before, the mail will be the email server will send a reply to the sender and saying that I'm busy. Then if the sender retransmit that email, then this email will be allowed to go through. The defense mechanism is based on the reason that if the email is generated by spammer will not bother to generate a second try for that for one particular spam email. They send tens of thousands email to tens of thousands users only once. They don't bother to receive a response that retransmits a spam to that same user. So that's the defense way. Of course, this defense way can be easily circumvented if the spammer create their spamming software that respond to this gray list transmission, then this will not be successful. So this is a gray list. Puzzle and capture, they haven't been used that much. Spam assessing is also another very popular spam detection software. Spam assessing is a rule-based spam filter. Rule-based spam filter basically means that it has defined hundreds of rules, such that if an email after checking it violates any of these rules, then this email is highly possible to be a spam. So many rules each rule will give a score for an email. Where either this rule will check this sensitive keyword, or the rule could check the email header, whether the email header has some weird text or some unreasonable text. So for every email, you could give multiple scores for the email checking. All the score will add it together. If the score is too high, then the email will be treated as a spam. So that is called a spam assessing. And you can find the spam assessing the rule set here. So here is a spam assessing the rule set. So like for this rule, it check the body part of the email and check whether this has mostly text or non-text. Then it will give a score for satisfying that rule. For example, this rule actually creates some trouble for international users. Like this rule, character set indicate a foreign language. Then this rule will give a 3.2 score for this email. So that means that if you receive an email not composed by in English, the email will have 3.2 score on it because the language is not in English. Then your email, if you are not not English speaking person, you got email from your friend, is from a foreign language. Your friend email is highly possible to be treated as spam because it has 3.2 score. For spam assessing, if the overall score is over 6, the email will be treated as spam. So this foreign language based email will highly possible to be treated as spam instead of normal email. So this could be could cause a lot of false positive for those foreign speaking users. So you can see there are many rule set. Some some of all those rule set will give a score to an email. Then all the score will add together. If they are over 6, then this email will be treated as spam. So that's how this works. And for this email, we can check it's well, it doesn't verify by spam assessing because this is Microsoft. Microsoft has its own spam detection mechanism to verify this is spam or not. So this is added by Microsoft Exchange. I don't have an example for spam assessing anymore because our CS department does not have an email server to process the email anymore. Oh, shoot. Phishing and farming is, I have mentioned a little bit. Phishing is that when you receive an email that look like this, when you click the link, you thought that because you have an account on Chase, when you click the link, the web page will look exactly the same as the Chase bank website. But actual URL will be some very weird URL showing up. If you don't pay attention to the URL, don't verify whether URL has been verified by the browser or not. When you put in your username, password, your account will be revealed to the attacker. Usually, such kind of malicious web page, they don't support SSL because in order to support SSL, they needed to have a certificate. In order for them to have a valid certificate, they need to submit their information to certificate authority. Attackers certainly cannot submit a valid certificate, their information to certificate authority. So they don't have a valid certificate. So usually these malicious websites, they use HTTP instead of HTTPS for connection. And secondly, usually these websites, they are short-lived because this website can be quickly discovered by defense community. So it can be quickly put in a blacklist. So attacker, they could create multiple such kind of malicious web server. Each web server only serve for like 10 minutes or 1 hour. Then they move on to the second malicious web server. Common phishing method, they can use a domain name where the legitimate domain name is put in the front. Because for the domain name, what matters most is last two sections. The first sections, they are not really important. Like for all the computer within UCF, they all ended with ucf.edu. So the first, the name before UCF.edu, you can create it arbitrarily without any problem. But UCF.edu is what ended the domain name. That is what matters. So if this domain name, you should not say that, well, this is ebay.com, so I'm connecting to eBay. What matters most for the domain name is the last two sections. Basically, this is a company name. So that one you need to pay special attention, whether you are connecting to the real Bank of America or you are connecting to some other website. Secondly, if URL have this, then you should be careful. This just means that you are connecting to chase.com, but actually it has been redirected to this second URL. So you are actually connecting to the second URL. So that is a redirection. Many web servers, they support redirection, then that could be exploited by attacker. And the browser, they will give you some warning if the browser cannot verify the certificate. Some browser can give you some warning if they think this website is a phishing website. So this is HTTP. This is HTTPS. If it shows as a lock, then this is a verified website. Farming is more advanced phishing attack where attacker also try to poison your local DNS server. So that need attacker to do additional job. They need to poison your local DNS server. Then in that way, they don't need to use a fake web link anymore. They can use a real web link, but your browser, when your browser try to do DNS query to the local DNS server, your browser will get the wrong answer from local DNS server because it has been poisoned by attacker. So that's called farming attack. So farming attack need more advanced techniques by attacker. But it's also harder to be detected by end user. Some website they try to defend against that using this so-called site key. Basically, ask you when you create the account on that website, they ask you to pick an icon, a small image from a large list of image list. And later on, when you connect to the website, you should verify the website give you the correct image or not. If you have used this car as your image when you connect to this bank, later on when you connect to the bank, this image should always show up. If this image is not show up, then you should not trust that you are connecting to the real bank website, because only the bank website know what's the image you have picked. So that's the idea behind this site key. But research paper, well-known research paper in 2007, it shows that this is actually an empire's cloak, empire close. So this will give you a wrong security. It's actually not secure. This paper showed why this is not secure, because attacker can get what image you have picked before they do the attack. There is easy way for attacker to know what image you have picked when you connect to the real bank website. It's called man-in-the-middle attack. I will not explain the detail, but the basic meaning that the site key can be easily obtained by attacker. Another defense method called keylogger to defend against keylogger. This is not for spamming. For keylogger, especially by bank website. Keylogger is that if your computer has been compromised, attacker could install a keylogger program to know what key store you have typed. In this way, attacker can know when you log into a bank website, what's the password you have typed in when you log into the website. So how does the bank deal with that? Bank, like this bank, when they ask you to input your password, they ask you to use the mouse to click the number on this image. And when you click, suppose your password is 1234. When you click this 4 button, the actual password you send to the bank is actually a space B, F, G, actually those 4 characters. So a keylogger will only know that these 4 characters is what you send to the bank. But actually the password you indicated is 1234. The bank web server knows that because this web page this image is created by the bank web server. So it knows that which button you have clicked. But the keylogger, attacker's keylogger cannot see that mouse operation. So this is a way to deal with that keylogger issues. Of course, right now, the easiest and the more secure way is use two-factor authentication where everyone has a cell phone. So the easiest way is just to send a text message to your cell phone and you input the code in that text message. So that's a common way right now used by all the bank and the e-commerce. Of course, some bank they want to be safer. they will ask you to download a secure app. The secure app will have this dynamic generated token. Then every time when you log into the bank, you need to input what's the code on that token. That is more secure than text message, because text message, it's still possible to be obtained by attacker in this communication channel. Okay, I think that the last two is not that important. Okay, so that's all for the email spam and the email phishing. And just remember, I have released the lab assignment 2. It is due February 16th, so 1 week after the lab assignment 1 is due. So this one basically asks you to send this manual spam to our TA email account. So it's very simple. You can do it, finish it in half an hour. Okay, that's all for today's class. And see you next Monday.
Thank you.
Thank you.